Okay. Well, for people joining this live stream, we are talking about various language features as we come to the end of the version 12 language design cycle for Wolfram Language. Okay, first is a lovely function called subset map, which is essentially supporting reversible functional programming that is going to be useful for all kinds of things, including quantum computing and other such areas. By the way, where have we got the current version of our quantum computing package? Where is it a distributable package and we're going to put it in the function repository and things, or what's the story with it?
At the moment, we don't have it in the master copy. So, yeah, the plan is not to have it for 12.
Right.
Yeah,
I understand, but we might be able to at least put it in the function repository and things.
We could. The problem is that it's not a package that it's a collection of independent functions. They are all quite interlinked. So,
how many are there? Like 5 or 6?
At the moment, it's about a dozen.
Wow. Okay.
But my worry is that they are too interlinked to be naturally implemented in the function repository.
All right, let's take a look at subset map.
Yeah. So 2 short questions. One is if you go to the scope area, where I was looking for examples, I realized that the third example, this one working with the even letter palindromes. So I was wondering whether this function should do something special for strings.
So I'm trying to understand what this is doing.
Yes, so it's separating the characters of those words and then reversing the even ones to show that you get the same thing back.
Yeah, I understand. But I mean, map could do something special for strings too.
Yeah, that's a good point.
I mean, we don't have a string map. We could. You turn it into a list and then you do it. I think that's fine.
Okay. And the second thing, if you go to the very end, yes, so I updated these to have a logarithmic axis in the number of steps to show that the action happens more or less in the middle.
That's cute.
Yeah, so the further down in possible issues, oh, there is a comment from the editor. Yes, so the problem is that when we specify the previous one, when we specify the list of positions in an unordered way, what we get is a bit surprising. I think it's correct, but I wanted to make sure that you agree with that.
Okay. If the list of positions is not ordered, let me try to understand this.
Yeah, exactly. It's not easy.
Okay, so you're first doing. Okay, so 3, 2, 1 is a single gulp.
Right. We're extracting positions 3 to 1, so CBA.
Okay, so then that is fed to accumulate.
Exactly.
Is fed CBA. And out comes that.
Right. And now we insert C in the third position, B in the second position, A plus B plus C in the first position.
Wait a minute. We took 3, 2, 1 out. Oh, and then we're inserting them back in positions 3, 2, 1.
Exactly.
So yeah, well, that's what's going to happen. Yeah.
Right. Yes. So it's just, I was wondering whether a sort somewhere was helpful too, but I think users should provide the positions sorted if that's
if that's what they want, then they should sort them.
Exactly.
And you should probably give that. You should probably put put a second example here, which has sort in front of the 3, 2, 1.
I see. Yeah.
Because what that will do, presumably,
Yeah.
what on earth? What happened here?
It's merged. Perhaps you don't have. Oh, put system in front. Perhaps it's the same problem we had yesterday.
If that's the case, Sushma, maybe you can report this. Yeah, it appears in system and global. Maybe you can report it to.
Still doesn't work. Okay, so there's something strange there. But this has been merged.
Okay. All right.
Okay, so that's solved. And then, yes, knitting
of this function. Shouldn't map thread be in that list of see alsos?
Yes. Mm-hmm.
And do we have back pointers here? To can you put those in, or
I can put them? Yes. I was thinking more about the guide pages where to put this.
Mm-hmm. Okay, let's figure that out. Okay, so let's go. Okay, so we want to look for map thread. Oops, won't appear ever. It'd be nice if we were doing, if we were using our own technology for that searching, and we should be. I should get myself a version of this that uses our text search. Okay. Applying functions to lists. Okay, well, let's look at several of these.
The first group seems the most appropriate.
That one there, you're saying?
Yes.
What's the difference between block map and array filter?
Cannot answer. Certainly, block map is very related to subset map.
Yes. And I think arguably should be the first link there.
Mm-hmm.
All right, I think here we want to have a section called there's kind of a family of multi-element. Okay, I would argue here we might want to say multi-element
Mapping.
mapping. Then we'd say map a function onto blocks of elements. Blocks. Okay, now, oh my gosh, why did that? Okay, and subset map. Map a function in place. And now array filter, we need to know what that does. I do not know the difference between these. Could somebody see if you can get Shoddy on the phone?
Sure, yeah.
Okay. Now, where else should we yeah, I think that's the main.
Mm-hmm. Perhaps in the previous one, together with the list, this list map thread, map add, map.
What is this thing? Hold on a second. Yeah. So hold on. What does block map? Oh, it says block.
So I think array filter is specifying what you want back, 10 objects. No, sorry. It's doing some, oh, it's taking the neighbors. The other one is blocking.
Yeah, the block map I understand.
Mm-hmm, mm-hmm.
And Shadi is here.
Hi, we are trying to understand the difference in block map and array filter. Array filter appears to be a very cellular automaton-like function.
Right.
As opposed to block map, which appears to form the blocks and then map.
Yeah.
Like
if you remember, block map is just partition map. Exactly. It's just a wrapper around partition map.
Yes. Sorry, here, by the way, I think we should put in both block map and subset map. There. Sorry. Now, okay, so what is array filter?
It seems to be applying the elements to the neighbors. Sorry, the function to the neighbors of a given element.
Yes, that's right. I mean, I think it does. It's like an elementary, it's like a cellular automaton, but why is it different from?
I think it's really the argument spec. Array filter is doing neighborhoods, the range specification, rather than the length specification.
I
see. One defines radius, the other one the length.
Should we mention array filter here, or should we just leave this as block map on this page about?
I think it should be mentioned. Map on elements and on neighborhoods of elements, something like that.
Okay.
And also notice that we have the template in array filter. So some subtle differences there, but the essence of the two functions are the same.
I see. Okay, map. Apply a function to neighborhoods. To neighborhoods in an array. Okay, I think that's what we needed you for, Shadi. Thank you very much.
All right, thank you.
Okay, bye.
Bye.
I sure hope array filter points to... How can it not point to list convolve? Oh my gosh, there's so many things here that need to be... Okay, so this should point to list convolve somewhere. Yes, and a good suggestion made on a live stream. Add examples of array filter and block map to each other's properties and relations sections. I completely agree. So... this should have... Okay. And right, list convolve. Okay, let's see, list convolve should also get array filter. Oh my. Okay. All right, I think we're good with this. So you will do the remaining knitting for subset map, yes?
Yeah.
Trying to think if there's any other place we need to insert it, like for example, anything about in-place operations?
Do we have a page for that?
I don't think so. All right, let's assume that's good. Okay. Onward. So, use of working precision in angle path. Yeah, well, I strongly support that. Angle path, you just have a little turtle and it goes bonkers because it takes too long.
Mm-hmm. Yes. And what could be the threshold? If we have some sort of automatic threshold, would the 100 be okay?
I think it should be smaller than that. I mean, I think by the time you've got 100 steps in an angle path. Okay, so let's look at this. I mean, if I say angle path, let's say range of 100. Okay, so that's some symbolic thing. Mm-hmm. And now I would say graphics of line of that. Okay, that was fairly fast. But if I go up to like 10,000, even 1,000, yes, there's a noticeable delay, and that's just stupid.
Right.
So maybe the threshold, you were suggesting 100?
Yes.
I mean, because if I do this numerically, mm-hmm, right, this will be like blindingly, well, he says it's blindingly fast, but that was far, actually, that's interesting. Let's find out what these, let's find out how long they took. Yeah, blindingly different.
Yep.
Right?
Yes.
Okay, I think we should add a working precision option. I mean, this is probably, it's not for 12.0, I guess.
It will be fairly trivial for me to add this.
Okay, well then let's do it.
Yes. So the question is, 100 is okay? Do you agree with 100?
I think 100 is fine. Okay, so angle path has option. What's the option? Which determines the precision of numbers generated. But the default setting exact numbers will be generated until only for small short paths.
Well, we have to say that for exact input. So it's not.
I see. Exact numbers
will be generated for exact input.
Only for fairly short paths.
Mm-hmm.
For longer paths, machine precision will be used. Okay.
Mm-hmm.
Okay, if you can trivially add this, let's do it.
Yeah, I do this for angle path and angle path 3D.
Excellent. Okay.
Mm-hmm.
Save the turtles. Right. Okay. Sorry. Okay. Okay, axiomatic theory. So is axiomatic theory in the build now?
In the X kernel.
Okay, let me admire it. If the thing ever comes up. Where is it? Help. Sushma, can you just make people aware of this unbelievably slow startup, which I've been seeing for the last few days?
Yes, and that's only in prototype?
No, both of them.
Okay.
Okay. So in prototype. Okay, so if I say axiomatic theory, do we have autocompletes yet for things? And I say group theory, for example.
I think it's group theory axioms.
Group axioms.
Group, yes.
Why are we calling it that? Why is it not group theory? That's fairly swank what it does.
I think we had a discussion about this, and I can look back through the notes, but there was because of the situation that we had with like figuring out what objects the axioms are semantically describing. I think we came to the conclusion that group axioms made more sense than group theory, particularly given that there are several equivalent axiomatizations of the same thing.
Hey, Sandra on our live stream is asking a question, which I would like to check here. So he's asking what happens to, so right now and in what we're planning, if you have up to 100 steps, no problem. The octagon will redo itself. Now, if we do numerical values here, let's numericalize that. I don't think there's going to be a problem. I think there is eventually. Okay, this is starting to thicken, right?
Mm-hmm.
And at 100,000 steps, I wonder if it'll be thickening. Yeah, there's some minor thickening there. Well, that's life in the world of approximate numbers. I don't think there's a huge problem with this.
Right.
It will close perfectly, and you probably should put that in possible issues. That whether the thing closes perfectly and so on.
Right. With working precision infinity, this would be avoided.
Right. Exactly. Okay. Let's admire some axioms here. Okay.
If you do a semantic theory bracket, you get the full collection.
I know, but I think that's a horrible thing. Okay, that's my lovely axioms. Okay, so what you're asking here is, should find equational proof of theorem, theory be accepted? Yeah, definitely. Why not?
Okay, so then a follow-up question is, where you have a notable named theorem, should you be able to request for that theorem? So should you be able to say,
where do we get notable named theorems?
Well, so as a second argument to axiomatic theory, you can call notable theorems, and you get back I think it's an association of notable theorems. And so,
what on earth is that first one? What is that?
That's one half of the proof that the Wolfram axioms are equivalent to Scheffer's axiomatization.
But that is just the Scheffer axiomatization, isn't it?
Right. So
yeah,
if you want to prove they're equivalent, you have to prove one from the other and vice versa. Right.
Okay, so for example, if I look at group axioms, notable theorems, by the way, don't forget to get the autocompletes working for these. What is the ordering of these notable theorems?
Right now, there is none.
All right. I mean, this is certainly not the most important notable theorem of group theory.
Mm-hmm.
Let's make some minor effort to order them in a sensible way.
Sure.
Like here, we could start with commutativity and so on.
Yeah, maybe simplest. I mean, like shortest to write down theorems should go first or something.
That would be an easy way to do it. Yeah.
Yeah.
But I think these ones that are the connections to other theorems should
be at the end.
I think so. Yeah. Because that's meta mathematics effectively, rather than, I mean, let's put math before meta math.
Right. That's a good adage.
Okay, those are alphabetical order, right?
Yes.
So the question is, should you be able to call something like find equational proof, Wolfram axioms, commutativity?
No, but you've got that the wrong way around. Unless we change find equational proof, which we've already cooked the goose on, right? By the way, when is this raft going to be fixed? It's still looking wrong. Sushma, could you please ping that again?
Yes. Okay.
No, I mean as a list in the first argument, that you say you have a list where the first item is the theory and the second item is the theorem, and then you pass the axioms in the second argument of find equational proof as normal.
What? Why is there a theory in the first argument? I don't understand that. Okay, by the way, did find equational proof end up with the nice new centrality based appearance?
Yeah. Oh no. It has half of it. It has the logistic sigmoid rescaling that we added, but I'm not sure whether it has the between the centrality weightings. I can add that if not.
Okay, so let's take a look here. So if we find equational proof of, okay, I just want to actually see what this feels like. So then what you've got there is that, okay, and so what you have here would be notable theorems, and then I would say commutativity. Is that correct?
Right.
And you are proposing, okay, so this will now grind away, hopefully. Hey, what's the status of the memory leak?
Has Marcus replied?
Not yet. We are waiting for a reply from him.
How could, okay, come on, we can find him. There's some issue here. There's some problem. Come on, that doesn't make sense. That he's been
Incidentally, it's not really a memory leak. We found it is just this math link.
Okay, but then he's not probably the expert person. So can you get hold of Shadi and ask her what, maybe he just is not replying because he has nothing to say, in which case that's really bad because it should go to somebody else. What am I doing here? Proof graph? Is that the name?
Proof graph.
Okay, that's still the old one.
Yeah. Jose was mentioning that the nodes look too small. I now realize why that's the case. Because in the new graph rendering, I have the logistic sigmoid rescaling, but not the betweenness centrality rescaling. Whereas it really makes sense to have both. So I'll modify that now.
Okay. Well, so is that the only form that we're giving for the proof network? Is the one with the betweenness centrality?
We could offer both.
How?
I don't know. Proof graph and proof graph weighted or something.
Yeah, that's what I'm thinking.
I don't know which should be the default. Probably
well, neither is a default. I think the weighted should be.
In which case, what do we call it? We call unweighted proof graph is the other.
Well, I don't know whether it should be the default. I think we should have it as a non-default. I think it should be weighted proof graph is the thing that if you're in the know, you use. Or should it be proof weighted graph? Weighted proof graph is fine. I mean, there's no default, right? So I mean, there's no default at all. So now you've changed the documentation here so that it probably should be called proof graph weighted if it's going to do that.
Right.
By the way, somebody on our live stream is saying that percent needs an overhaul. I 100% agree. We have a beautiful design that we're just waiting for time to implement. Thank you for supporting that idea that percent needs an overhaul, because I've been pushing that for several years. Let's call it, if we can here, proof weighted graph. Does that make sense? Or proof graph weighted, which do you think is better?
Proof graph weighted sounds more natural to me, at least.
Okay. Emphasized, with central lemmas emphasized. Okay, can you implement that easily?
Yep, that's no problem.
Okay. Should we flip around the defaults? No, I don't think so. I think it's more honest to just give this. I mean, the other one is interesting, but I think this is the more direct version.
Right.
Okay.
And the sizes, this looks a bit small to me.
Yeah, I mean, it's got to be gotten right. What we had before was right.
This is using the sigmoid model that we designed.
Right, but the sigmoid model should not be engaged unless there's a betweenness centrality weighting.
Okay.
Right?
So for the default, like just unweighted proof graph, you want to use exactly what we were using before.
I think so. I think we optimized it well.
Okay. Yeah. I'll modify that.
Okay. Okay. So find equational proof. Okay. This obviously should talk about, and you haven't even started talking about that. It should point to axiomatic theory. Is there a documentation page?
There is not. And in fact, I wanted to ask, how involved do you want to be in the documentation for axiomatic theory?
I want to look at it. I mean, do we think? Yeah. So the answer to your question is we absolutely should have it be the case that. I mean, should we make a bit of beginning of a page for axiomatic theory?
That would be great.
That's up to you. Yeah. But yeah, I mean, for me at least, the key thing is to nail down what is the correct design for this notable theorem stuff. Or I mean, should we support that at all? Where you can just prove named theorems directly and find equational proof.
So your proposal would be that you'd be able to say just commutativity there.
Yeah, this is the thing. I'm not sure whether it should be a list of Wolfram axioms, commutativity, or whether Wolfram axioms should be implicit.
No, I think it should be implicit. If what you say is this, if what you've got is not that but this,
right?
I mean, that might as well work.
Right.
So that means the commutativity theorem of the Wolfram axioms.
That is correct. It means exactly what I wrote up here.
Yeah.
And if it isn't a notable theorem, then it should error out saying that wasn't a notable theorem of that axiom system.
Right.
Mm-hmm.
I think it's pretty neat that we've got these axioms as kind of anyway. Okay, so what we're going to have to do for now, unfortunately, is we're just going to have to make a table of all of those 17 axiom systems. Make sense?
As documentation?
Yeah, in the documentation. I mean, it's unfortunate, but I think that's what we should do.
Okay. What about in the future if we have, hundreds of these things?
Well, obviously, what we're going to go to is something directly analogous to what we've gone through for interpreters and other things, special documentation pages for axiom systems. Okay, it will be a category of documentation page for axiom systems, just like we have ones, import-output formats, and et cetera, et cetera, et cetera. Okay, so this means that in here, let's see. I think just to help people out here, we should do this. We should say find equational proof theorem, name. Tries to find a proof of THM using the named axiomatic theory. Specified named axiomatic theory. And then we probably want to say down below, oh, mess. So find equational proof of THM, common name, is equivalent to.
Should it be name or theory?
Okay. It's equivalent to find equational proof of theorem, axiomatic theory of quotes theory. Okay, and then we can also add another line that says find equational proof tries to find a proof of the named notable theorem from axiomatic theory, comma, notable theorems. Okay.
Should that possibility be detailed at the top, or?
I don't think so.
Okay.
I think by the time we've got this, and we can give this in some examples as well.
Sure.
Yeah, and so here you can...
Exactly. Now we can change this.
Right. Right. Okay. So we got a question about which theorem proof is being used. So this is primarily a equational logic theorem proof called Bullmeister. We are working extensively on things with lean and some other theorem provers. And in terms of interactive proof assistance, yep, there's interesting things coming in that direction. Could machine learning be used to make the prover more intelligent? Yep, we are looking at that. Although, frankly, it's pretty good right now. Really quite good, quite impressive. I mean, certainly, all I can say is that years ago, with this technology stack, I proved theorems that people have been trying to prove for like 20-something years pretty easily. So it's certainly beyond human performance in many respects. All right, let's document axiomatic theory a little bit here. Okay. Okay, axiomatic theory of theory. Now, what should it say? Gives a representation so if I say axiomatic theory of group axioms, and so here we should say where's the examples? I don't usually do this part of things. So insert text, right? Give the standards, give a statement of the standard axioms for group theory. Okay, so here, all right, so I don't know how much, we're going to run out of time on this. So, I mean, I think, let me just, are we making this experimental or not? I guess we should. Everything else in this general area is experimental.
I think so.
Yeah, it really should be.
Okay. Gives a representation of the axiomatic, of the named, gives a representation of this, of the specified named axiomatic theory. The axiomatic theory with the specified name. Well, no. Of an axiomatic, of the axiomatic theory. Okay, so that's the most basic thing. Gives an axiomatic representation, gives... Is that a reasonable way to say it? I mean, so what we're going to want to say here is axiomatic theory by default uses... Now, what is it using for the variables? Uses...
formal symbols.
And what happened to the function that generates formal symbols? Do we have that now? That formal symbol function? Did we implement that in the end?
No, we don't have that.
Not yet. Okay. By default uses formal symbols such as formal A to represent variables. Is that right? Axiomatic theory by default uses operators such as circle times and center dot.
Should we specify that these are operators without predefined meanings?
Yeah, without predefined values, such as, by default uses operators without predefined meanings, such as, without predefined values, such as,
Without.
Thank you. To represent operators. To represent operators in the theory. To represent variables represent essentially local variables in axioms. What should we call them? To represent
scoped variables.
They're not scoped. What do they call in formal logic?
I mean, free variables is what they are, essentially.
Let's call them that. By default uses
symbols.
I think we should say such as circle times and center dot. Oh gosh, uses functions without predefined values, but uses functions with predefined formatting, but without predefined values to represent operators in axioms. Examples are circle times and circle dot formatted as, oh, it's a pity that's a period thing. Okay. So now what's the next thing we want to say here? So the axiomatic theory supports theories including, and let me just write out a few, and I think here what we should do is try and write it from which is the biggest axioms here? What are the arithmetic axioms? What do they look like?
They're not particularly big. I suspect field axioms are the largest.
Well, I mean, the question is representing the largest. Why are they so small? That's not pure arithmetic. There's no induction.
Right. It's not meant to be pure arithmetic. We never came up with a design for representing axiom schemas, so we can't.
Why are we calling this arithmetic axioms then?
They're axioms in which you can prove simple theorems of arithmetic.
Why don't we call them addition axioms, since that's what they seem to be about?
We can do that.
I think it's what we should do. Because people will look for pure arithmetic here, and they will be disappointed if they don't find it, which they won't yet. Because, I mean, when we have an axiom schema, what will we be able to use it for? Until we have a different family of provers, I don't think we'll be able to use it, will we?
Presumably not. I mean, there are presumably certain restrictions you could make if you specify finite models or something where you can make sense of axiom schemas using first-order theorem provers.
Okay, so the next case we have here is comma property, right?
Right.
gives the specified property of an axiomatic theory. I think it's cool that it's even conceivable to represent all these things here. Axiomatic theory supports. Okay, so now and then how do you specify the settings for the operators?
So that's passed as a list in the first argument. So you give a list where the first element is the theory name and the second element is an association of operators.
Okay, so we should change that there. Okay. And the free variables you don't get to redefine, is that correct?
That is correct, yep.
Okay, so this is op1. Operator 1 goes to, what should we call it?
Sim1.
S1, let's say. Uses a representation, uses S sub I to represent the operator named op sub I in the theory. Operator. Question from our live stream, is this related to category theory? Interesting question. Saunders MacLean always used to like to claim that category theory is not an axiomatic theory, but actually it has axioms like everything else. But I don't think we have the axioms of category theory here. Didn't I have them in the NKS book, the axioms of category theory?
Yeah, you did, but they're non-equational. So when we have find predicate proof, we can, in fact, that was one of the test cases I ran it on, was the elementary category theory axioms from the book, but because that's not in 12, it's not in axiomatic theory.
But so what is so axiomatic theory eventually will also support, what do you mean it's not an axiomatic? What is the characteristic? Does it have an axiom schema or does it have something else in it?
No, it's finitely axiomatizable, but it's not conventionally written in equational logic. It's written in full first order logic.
I see.
Much like, say, Presburger arithmetic, which we will also be able to support, but we don't yet.
When we have find predicate proof.
Yes.
Okay, that will be very interesting.
So we can do some category theorem proving, but it just won't be in 12.
Right. How is it going with the predicate thing? Find predicate proof.
Well, we need to have Jose and I need to talk more about it. I obviously I haven't been working on it very much, but the foundation is there. It works. It's mostly design stuff now, I think.
Okay. Supports the following properties, standard properties. Properties, what are they?
You can do axiomatic theory properties. Operator rules has been changed to operator arities.
Okay. Okay, list of axioms. List of axioms. Should we say something about stated and first order logic, or we don't just say that? And no, we don't just say that.
That will change.
This should link to entity pages. By the way, that's a thing, that's for Sushma. That's a general thing we need to do is now that we have entity pages, we need to think about how we link from functions to entity pages.
Okay.
That may need a discussion with the documentation team.
Yeah.
Just list of axioms. Okay, what's the next thing you think? Should we list operators? What is operators? Operators used in the axioms. Names of operators used in the axioms.
Well, it's names and symbols.
What does it look like?
It gives back a list of or an association, actually, I think, of operators and their symbols. So it'll say multiplication, arrow, circle, dot, or whatever.
Operators and their representations or their
default representation.
Is it default?
No, because if you override it and then call operators, you get back the new representation.
Oh, yes, you're right. Yeah.
Okay. So the next one is operator arities. And the next one was that operator groupings. Is that right? What were we calling it?
No, in the end, we are not separating the other one.
Okay. So that's suitable for use in grouping.
Yes, exactly.
Operator arities gives a list suitable That's going to be a nice feature in that. There are worthwhile examples to be given about that.
Yeah. Mm-hmm.
Okay, notable theorems. Association of notable theorems. Well, notable named theorems in the theory. Mine named. We don't have to. Well, notable named theorems in the theory. Okay, and then I think I can leave you guys to do this. Well, we're going to call it sub-theories. Okay, yes. Equivalent theories. Theories equivalent to this one. Names of theories equivalent to this one. Theories that are named theories that are subsets of this one. Is that right?
Yeah, sort of.
That can be proved from this one.
Right. Although that's not quite. That's not quite right, because if the theory is equivalent, it can also be proved without being a sub-theory. So
names of theories that contain this one, that are contained by this one.
Right. Yeah, I think that's the right way.
All right. Axiomatic theory supports theories including, and I'm not going to fill them all in right now, but let me just fill in one. Group theory with standard axioms. could be the start there. I don't know what order we should do these in. Any thoughts?
Perhaps.
What happened to my other axioms? The axioms with commutativity.
They are not in there yet.
And by the way, you should say axiom. It's just one axiom.
Interesting, but it would be a bit of an exception. I mean, it is an exception, but I'm not sure.
All right. Okay. Well, fine. Yeah. What's that?
For things like the McCune axioms of group theory, technically the way we've represented it is just as a single axiom, but they're conventionally referred to as the McCune axioms.
All right. Fine.
I think the important thing is that we always return a list. And that's
fair enough. Okay, fair enough. All right. So, what are we going to call that other axiom of mine, the one with commutativity?
Abelian Wolfram axioms. No, or commutative.
It's not abelian because it's not an abelian theory.
No, that was a joke.
Partly a joke.
Commutative Wolfram axioms? It doesn't seem unreasonable.
Okay. There are also alternate forms of my axioms which are kind of interesting, which are in the NKS book, and we might as well have them since they're available, so to speak.
Right.
I don't remember how many there are. There is one inequivalent. There are several inequivalent ones. See if I can look them up.
I can get PK, the summer camp student, to comb through and add these things.
That would be wonderful. Is he going to add lattice theory and things like that also?
I don't know. I mean,
but there's lattice theory in the notes in the NKS book.
Yep. Okay. Let's get that. I mean, I focused just on getting all the ones from the main text. But yeah, okay. If there are other things in the notes that are of interest,
right? Look, there we go. There's an alternate form.
Okay.
So there's that one, which is the commutative one. What is that one there? Is that David Hillman's one? Or is that something yet different? Oh no, E is the Meredith axiom system. So let's please get that.
Sure.
Okay, so then we're having, let's just make a note here. So they'll end up being Meredith axioms. They'll end up being and probably alternate Wolfram axioms, which is that last. It's a little bit annoying that the ordering is that. Let's do this. Let's say Wolfram commutative axioms, Wolfram alternate axioms. And then let's please, I'm pretty sure the notes, okay, somebody on the live stream is asking, would you be able to know if you have the shortest proof? Good frigging luck. No, it's in general undecidable. We do our best. That's why we use the word try in find equational proof. Be super impressed that you can get any proof at all.
Right. There are speed up theorems and things which show that it's undecidable in general.
Indeed. Okay. So fine. All right. Let's get a draft of this page if we can, and then we'll go through that. And yeah, this is a lovely thing. This is a lovely thing. Cool. Do you think PK could also get some notable theorems, some other notable theorems for some of these things?
Yeah, probably. I mean, these were just things that I could think of. I mean, I had no particularly systematic process for producing these things. Presumably, he can think of more.
And as a QA matter, you did prove all the notable theorems from those theories.
Yeah. They're all decidable. It's okay.
No, I understand. What I'm saying there is those are good test cases to use. Mm-hmm. I mean, they should be in the test suites probably. Yeah, let's try and collect some more of these things.
Sure.
And it's remarkable that mathematics can be compressed into this, you know, I don't know. I mean, the other question is for groups, for example, is there a way of getting, of specializing to a particular group?
I mean, that's where we get into model theoretic stuff. We still haven't completely worked out how that should work in the context of like finding counterexamples and things.
Right. By the way, what is that 1 tilde thingy?
That was you suggested that as the identity element.
Okay. All right. So constants, axiomatic theory by default uses functions let's say to represent operators and constants in axioms.
Sure.
I leave it to you to figure out what we do with this. And, well, I don't even know how we do that here. What would we say? Just the tilde for the over tilde, right? I think we just do this. Except there isn't an over tilde, so I'm confused.
Perhaps we can have one of these, how is it called? This square representing something to be inserted.
Oh, yeah, placeholder.
Yeah, placeholder, exactly. And we put an over tilde over it.
Okay. All right, I'll leave this to you to do. Now, have we failed to get, shoot, I have to go to a different meeting here. Just a minute, what am I late for? Oh, I really got to go to this one. Let me see, what have we failed to do here? We haven't talked about, oh gosh, you've got I really got to go to this.
Yeah, I can, I mean, it was just a matter of future action for tomorrow. I need more examples, but
you have to say how it's displayed, right? And also, don't we have isn't there an infix? Isn't there a way to enter the thing?
Not yet, no.
But if I say around X, oh, I don't know why it doesn't, okay. Okay, look, Jose, if you want to go over this with me, if you're available sometime this evening, we could go over this in more detail if you think it's useful.
Of course.
Okay. All right, sounds good. Okay, thank you, Jonathan.
Thanks.
And everybody else here. Oh, question for the live stream. Those are always fun. Can a game like chess be included as a proof theory problem? Actually, somebody did a really nice project about related things at the summer school this year. You can look it up. Yeah. Okay, good stuff. All right, thank you all. I will push these changes back.
Yeah, thanks.
Okay, see ya. Okay, bye-bye.